Hello everyone. The title of this video is Simplifying Expressions with Roots or Radicals. Roots, radicals mean the same thing in mathematics, pretty much. So every exercise I'm going to do in this video is coming directly from a free online textbook at openstax.org, and I'm in their Intermediate Algebra 2nd edition text. I'm in section 8.1, titled Simplify Expressions with Roots. And in this video I'm going to be working on exercises 1 through 18 and all the parts. Okay, so parts A and B for 1 through 11, and parts A, B, and C for 12 through 18. So that's 18 problems, 18 examples with multiple parts I'm going to be going over. And I will have timestamps for when each new question begins in the description of the video. So this one's very easy to follow, right? Example 1 in the description is just going to be question 1. Example 2 will be exercise 2, and so on, right, all the way till example 18 will be exercise 18. Very easy to follow. So you can use the timestamps in the description of the video to, bounce around and see specific problems if you wish. Also, I would request that when I start a new question in the video, pause the video and try to do it yourself first before watching me do it. Right? Because if you're just watching me do it and not practicing on your own, you're probably not going to learn much. Alright, so example 1, exercise 1. Let's pull up some paper here. I've written them out. Now, in every single one of these exercises, we're asked to simplify what's called a radical or a root, which you see this symbol here. Now, actually, before I get into all these questions, I want to talk about, give a little lesson on roots and radicals. So roots, radicals. If you say this to a mathematician, they'll know what you're talking about, or any math student. Okay, so we start off first with the following. I'll start with square roots. Right? We'll start with square roots, and then work our way up. All right. So if, say, I'll try to use the same notation they're using in the text. If n squared is equal to m, right? If some number squared, right, to the second power, remember that means multiply it by itself, n times n, is equal to m, some other number m, then we say the following. 1, we would say that m is the square of n, right? M is the square. M is the square of n. Also, right, another thing we could say from this statement is that n is a square root, not the square root. A square root, and I'll show you what I mean. It's just one of the square roots of m, but it's a square root. of m. All right. So for example, let me box this in here. So for example, right, some easy ones. You know that 2 squared is equal to 4, right? 2 to the second power, 2 times 2 is equal to 4. So again, we could say that 4 is the square of 2, or we say that 2 is a square root of 4. And again, I say a square root, not the square root of 4, because there's another one. Right? There's another square root. You can see that over here, right? There's another number I can square to get 4. Right? So also, if you take negative 2, right, in parentheses, and raise it to the second power, negative 2 times negative 2, that would also be positive 4. So again, looking back up here, we would say that 4 is the square of negative 2. Okay? But we would also say that negative 2 is a square root of 4. So, again, a square root. So which one do I want? When you ask for the square root, notice that one is positive. Right? One root is positive. This is the positive square root of 4. And the other one is negative. Right? This negative 2 would be the negative square root of 4. All right, and this is going to happen in general for any positive real number. So I'll make that statement down here. Every positive number, right, every positive real number again, positive real number, has 2 square roots. One positive and one negative. And hopefully you can read my writing. And that's huge, right? So another example would be, hey, how about 9, right? 4 has 2 square roots, 2 and negative 2. 9 has another example, right? 9 has 2 square roots. It's a positive real number. 9 has 2 square roots as well. And these would be 3 and negative 3, right? Since if you raise 3 to the second power, you will get 9. And the same thing will happen for negative 3. Right? And I could keep going with this. Right? Say 16 has 2 square roots, 4 and negative 4. 25 has 2 square roots, 5 and negative 5. And again, I could keep going with this. But every positive real number has 2 square roots, one positive and one negative. Now the positive square root or the non-negative, right? Because the square root of 0 would be 0. The only that's why I emphasize positive here, because 0 only has one square root, right? And that would be 0. And you'll see later, negative numbers don't have square roots that are real numbers, but we'll see that later in the video. So the non-negative, I think that should be one word, but whatever, I'll hyphenate it. So the non-negative square root of a positive real number. Oops, square root. Sorry. So the non-negative square root of a real number, and a positive real number, is symbolized by the what's called the radical symbol, by the square root symbol. All right. So when you see this, right, when you see this square root symbol, so if I wanted the square root of m like this, what they're asking for, what this will be equal to, is the non-negative, right? The square root that's not negative. Right? The square root of m that's not negative. That is not negative. So I'm going to put that in another colorful box here. This is very important, because too often I'll see a mistake made. You know, if I said, what's the square root of 16? Right? Too often I'll see people make the mistake of saying plus or minus 4. Right? They'll put both plus and minus. They'll put both square roots. But that's wrong. All right? You see this symbol, what you're being asked for is the square root of 16 that's not negative. So this would only be positive 4. All right? And again, this is since 4 is the positive square root of 16, right? 4 squared is 16. Now, if they wanted the negative square root, they would just put a negative sign in front of it. Okay? So, only if they have a minus sign, a negative sign in front of the square root, then they're asking for the negative square root. Alright, so this negative square root of 16, that would be negative 4. Right? And again, because negative 4 right, to the second power is 16. Right? Okay, but you see the symbol without a negative sign in front of it, your final result can't be negative. Right? That means they want the square root that's not negative. Right? Sometimes referred to as the principal square root. Right? But I'll leave it this way, square root that's not negative. Okay. Great. And now I want to talk about, all right, what if, that's if I have a positive number inside the square root. Right? The square root of a positive number is fine. But what about negative numbers? Right. What about negative numbers? So what if I asked you to take, what's the square root of negative 25? Right, so notice that the expression inside, this expression inside is called the radicand. Right, this is called the radical symbol. So you might hear me say the word radicand. That just means expression underneath the symbol. The expression inside is a negative number. So when I say, hey, this is equal to, and then I'll ask the question over here, can you think of a number, right, can you think of a real number whose square is negative, right? And in this case negative 25. So basically you're solving this equation. Can you think of a number x such that when you square it you get negative 25? Right. Does this have any real solutions? Well, you might think, oh, what about 5? 5 squared, well, 5 squared is positive 25, and then you're saying, oh, well, what about negative 5? Negative 5 squared is also positive 25. Actually, there is no real number. Right? There is no real number you can square to get a negative number. And that's huge right here, okay? So what we're going to do when we come across examples like this, for this section anyway, we see the square root of a negative number. Like, hey, there is no number I can square to get a negative, right? Because if you take a positive number and square it, the result is positive. You take a negative number and square it, the result is also positive. You're never getting a negative. So all we're going to say right now is that this is not a real number. And that is all we're going to say for this section. All right. In future sections, we'll learn about things called imaginary numbers, which are the square roots of negative numbers. Okay. But for right now, in section 8.1 here, when you see a negative number inside a square root, simply going to say that it's not real. All right. Now, all the stuff I just said about square roots works for any even root. Any even root. All right, so I'm going to go now to just roots in general. All right. So sorry, I'll eventually get to the problems. So roots, or radicals in general, Alright, so earlier I was doing square roots. Now I'm just going to talk about nth roots. So square root is the second root. Then you have cube roots, which are third roots, fourth roots, fifth roots, sixth roots, and so on. Again, if, say, I'll use different letters this time. If b to the nth power is equal to a, right? If b to the nth power is equal to a, then we'd say the following. We'd say that, we'd say a is the nth power of b, should have used lowercase in there, whatever. Two, I'm going to start off here with, well, no, just say b is an nth root of a. Right. So pretty similar to squares. Right. If b to the nth power is a, you say a is the nth power of b, and b is an nth root of a. Right. Now, let's start with, we did square roots. Let's look at even roots. Because all the stuff I said about square roots are going to apply to even roots, right? So this is n equals 2, 4, square root, fourth root, sixth root, eighth root, and so on. And I'll start off with one example here, say with fourth powers. 2 to the fourth power is 2 times 2 times 2 times 2, that's 16. But also, right, negative 2 in parentheses to the fourth power, that's also positive 16. I hope you remember this, that a negative number to an even power, positive number to an even power, they're positive results. Right? So really, if you remember any number, any real number to an even power will not be negative. Right? So what does this mean? This means that 2 is a fourth root of 16, and negative 2, right, is also a fourth root. Of 16. And this will work for any even powers. The positive number to that even power will be the same as the opposite number to that same even power, right? Both 16 here. So for even roots, right, every positive number, right, like 16, has 2 even roots. So just like earlier with square roots, right, square is when n equals 2. Every positive real number, like 16, has 2 even roots. It's got to be even though, right? 2 even roots. 1 positive and 1 negative. So yeah, very similar again to what I said about square roots earlier. So once again, I'll bubble this, right? This is important. Right, and just like roots earlier, you see the radical symbol. Right? So again, here's what's called, once again, the radical symbol. And say I'm taking the nth root of a, and if you want to know what root is being taken, that goes here, and this is called the index of the root. Tells you what root's being taken. Index. So if that were a 4, it's the fourth root. If that were a 6, right, it's the sixth root. Now the only time you don't see this is when there's a square root, right? If it's not there, it's just implied to be 2. So again, if n is even, this symbol means, remember, because there are two even roots for every positive real number. So if I say, what's the fourth root of a, which one do they want? The one that's not negative. So just like square roots earlier, when you see this symbol, and it's a fourth root, a sixth root, an eighth root, they are asking you for the nth root that is of a that is not negative. Right, they want the non-negative one. Okay. So back up here, if I said, for example, if I said, what's the fourth root of 16? Well, we know 2 is a fourth root of 16. We also know negative 2 is a fourth root of 16 from earlier. But once again, you see the symbol, the radical symbol. What that's asking you for is the root that's not negative, right? So what's the fourth root of 16 that's not negative? That would be positive 2. All right, so please keep that in mind. When you see these even root symbols, the result is not negative, can't be negative. The only time it will be negative is if there's a negative symbol, a negative sign in front of it. So if they wanted the negative fourth root of 16, they'd put a minus sign or a negative sign in front of it. This would be negative 2. All right. But you should only have one number. Don't write plus or minus. That is incorrect. All right, and then just like radicals, just like square roots earlier, let's talk about negative numbers, negative radicands. Well, I know the fourth root of 16. What about the fourth root of negative 16? Right now, the negative is inside. Right now. Well, just like earlier, can you think of a number x to the fourth power that would give me negative 16? And the answer is no. Right? This equation here has no real number solution. Right? You take any positive number to the fourth, it's going to be positive, not negative. You take any negative number to the fourth, it's going to be positive, not negative. So just like earlier with square roots, if you see a negative number in the radicand, you're simply going to write that this radical is not representing a real number. And that's all we're going to do. Like I said earlier, we'll talk about imaginary numbers and how to express those, these even roots of negatives. We'll talk about those in later sections. But for right now, we're simply writing it's not real. Right? So yeah, so in general here, the even root of a negative number, so even roots of negative numbers are not real numbers. And that's all we're going to say. Are not real numbers. Alright, so I spent a lot of emphasis now on even roots, right? Square roots and fourth roots and stuff, right? The reason I spent so much emphasis on those right in the beginning is because those are the most difficult ones. I think they're the more confusing. Because sometimes, there's no expression, they're not a real number, you can't do anything with them. Odd roots are much simpler. Okay, so going back to the little statement up here, right? If b to the nth power is a, then we say b is an nth root of a. What about odd roots? We talked about even roots. Here's odd roots. So what if n were 3, 5, 7, 9? Now third root is also called cube root, right? Then you have fifth root, seventh root, ninth root, and so on. Now for my examples, if I raise something to the third power, take 3 to the third power, I'd get 3 times 3 times 3 is 27. It's not like even roots. Negative 3 to that same odd power is not 27. Again, it's negative 27. Remember, a negative number to an odd power will be negative. right? So every number, positive or negative, has a single odd root. Much, much simpler to think about than even roots, right? So, here 3 is the third root, or cube root. And notice I'm saying the now, right? It's the only one. Well, there are imaginary, okay. I shouldn't say that. But still, the real cube root of 27. And there's no other real number, right? There's no other real number I could raise to the third power and get 27. That's it. And same thing with this negative number here, right? Negative 27, negative 3 is the real cube root. Right? The only one. Third root, cube root of negative 27. Right? And notice, one output was positive, one output was negative. It wasn't always positive like when you raise things to even powers. So, and then I could do this with the 5th power and 7th power and 9th power, but so here, this is even easier. Every real number, not just positive real numbers, but every real number, positive or negative, has exactly one real odd root. All right, again, that's a huge thing. All right. So this makes taking odd roots quite simple. All right. So when you see the radical symbol, the nth root of a, and n is odd, okay, the result is just the odd root of a. The odd root of a. And this can be positive or negative. It wasn't like the even root symbol. Remember, the even root symbol, the result couldn't be negative. But the odd root, you see a cube root, a 5th root, a 7th root, a 9th root, this can be positive or negative, or 0, but I'm not going to mention that. Right? Hopefully you understand that the cube root of 0 would be 0. Right? But this can be positive or negative, right? Because there's only one. You don't have to worry about it, choosing which one. So one final simple example here before I finally move on to the exercises. So for example, if I said, what's the cube root of 27, like I had earlier, this would just be simply 3, right? Since 3 to the third power is 27. The cube root of negative 27, this is also fine, right? This would be negative 3, right? Because we saw earlier, negative 3 to the third power is negative 27. Okay, and I could do all sorts of these. What's the 5th root of 32? This would be 2, since 2 to the 5th power is 32. And what's the 5th root of negative 32? Again, this is fine. This is negative 2, since negative 2 to the 5th power is negative 32. Every single number you can think of has an odd root. All right, so it's not as restrictive as the even roots. All right, you just have to pay attention to the index. You have to pay attention to what kind of root I'm taking. All right. Great. All right, so that's it for the lesson. It was a long one, half an hour there, but hopefully that'll make all these problems go by pretty quickly. All right. So we're asked to simplify, figure out the root, right? So part A, I'm just going to remind you, we have this number 1 part A, we have the square root of 64. Remember, when you see this radical symbol, right, with an even root, square root here, the result is the root that's not negative. Right? The result can't be negative because this is even, right? The even root symbol. The only time it will be negative is if there's a negative sign in front, like in part B. So what is the square root? The positive square root of 64. Right? The positive square root of 64 would just be, now again, you're just thinking of what number to the second power would give me 64, and that would be 8. Right? So the answer is 8 here. Right? And again, that's because, right, that since 8 to that index, right, 8 to the second power is 64. Right? 8 is a square root of 64, but the answer is 8, positive 8. All right, then part B. Notice they want now the negative square root of 81. So this will be negative, right? You got a negative sign in front. Then what's the negative root? And that would be negative 9. Right? This would be negative 9. Right? Negative 9 is the negative square root of 81. I'll circle it. And again, that's because, negative 9 is a square root of 81 because when you square negative 9, you get positive 81. Okay. Yeah, so easy enough, I think. Now, obviously, with larger numbers, you're going to have to know some squares, some cubes, some fourth powers, fifth powers. But, I leave it to you to find those, figure those out. So example 2. Part A, again, this is the positive square root. The result should be positive. Of 169, this is 13. Again, I leave it to you to check, right? This is because, positive 13 to the second power, right? It's a square root, equals 169. And you check, do 13 times 13. It is 169. Part B, they want, the negative square root of 100. Well, remember this, the positive square root of 100 is 10, right? Since 10 squared is 100, so the negative square root of 100 is negative 10. That's, since negative 10 to the second is positive 100. Great. All right, so again, pay attention. Do they want the positive square root or negative square root? It's very easy to see because they'll want the positive one if they don't have the negative sign in front of it. All right. Example 3. Now the first, I think, 10 examples are all square roots. Part A, what's the positive square root of 196? And that would be 14. And that, since 14 to the second power is 196, and I'll leave it to you to check, what's 14 times 14. All right, now over here, part B, what's the negative square root of 1? Well, the positive square root of 1 would just be 1. Right, so this would be negative 1. Very simple, right? And again, since negative 1 to the second power is positive 1, right? The radicand. All right, number 4. Part A, what's the positive square root of 144? That would be positive 12. And I'm done. And that's because, 12 to the second power is 144. And that's how you check. Right? Part B, they want the negative square root of 121. All right, well, the positive square root of 121 would be 11. Right? 11 squared is 121. So the negative square root of 121 is negative 11 that they want here. I'll circle that and I'm done. Right? And again, to check, Just make sure that negative 11 squared is indeed positive 121, is indeed the value inside the radical, right, the radicand there. And it does work. Wonderful. All right, see, I'm flying through these now. After you read a lesson on roots, you should be able to fly through most of them, especially these, because all these are really nice. We'll see later, some numbers inside a square root that aren't perfect squares, but we'll get to that in later videos. So number 5, part A, what's the square root of 4/9? Now we'll see something called the quotient property in a later video as well. And when you take a root of a fraction, you can do the numerator and denominator separately. So what's the positive square root of 4? That's 2, positive 2, and the positive square root of 9 is 3. So the positive square root of 4/9 is positive 2/3. And again, let's check it. Take 2/3, raise it to the root, right? Raise it to the power of 2. And is that equal to 4/9? Absolutely. And then part B, they're asking for the negative, right? Minus sign up front. Negative square root of 0.01. Now you could write this as a fraction if you want, right? This is 1 over 100. And the square root of 1 is 1. The square root of 100 is 10. But they want the negative square root, right? This is going to be negative 1/10 or negative 0.1. And again, let's check, take negative 0.1, and it's a square root, so let's square this and see that would be positive 0.01, the radicand. Great. All right, number 6, part A, square root of 64 over 121, 64 121st. The square root of 64 is 8. The positive square root of 121 is 11. So the positive square root of 64 121st is 8/11. And then once again, I'll check real quick. Take 8/11, raise it to the second power. That would indeed be the radicand, would indeed be 64 121st. Part B, they're asking for the negative square root of 16/100ths, which would be negative 4/100ths, 0.04. Or sorry, 4/10. My apologies. 4/10, 16 over 100. Square root of 16 is 4. Square root of 100 is 10. So negative 0.4. My apologies. And let's double check that. If you were to take negative 0.4 and square it, you'd get the radicand, positive 0.16. That would be true. Okay, wow, we're flying. Example 7. Here we go. Part A, got an even root. They want the positive square root, but right, negative radicand. There is a negative number under my even root. And again, this is an even root. And I said it earlier, right? Even roots of negative numbers, we're just going to simply say right now that this is not a real number, and that's all. All right, in later videos and later sections, we will see how to express this as what they call an imaginary number. But for right now, it is simply not a real number, right? There is no number, no real number, positive or negative, that I could raise to the second power and get a negative 121. Right? Because anything you raise to the second power is going to be positive. Any real number you raise to the second power is going to be positive. It can't be negative. So there's no real number that makes that work. But part B works. See, the radicand under the square root is 289, right? This is a positive radicand. The negative sign is outside, so they want the negative square root. Remember, every positive number had a positive square root or a negative square root. They want the negative square root. So positive radicand, that's okay. That's cool. we can do this. And what's the negative square root of 289? That's negative 17. And let's check that. Take negative 17, square it, right? Negative 17 times negative 17 would indeed be positive 289, and I leave it to you to test that out. Great. And number 8, part A. Notice, the radicand is positive, right? So it's fine. We're taking an even root of a positive number. That's cool. The negative sign's on the outside, right? So this is asking for the negative square root of 400. So they want negative 20. And again, let's check that. Let's take negative 20, and this is a square root, so let's square that and see if we get 400, and we would, right? Negative 20 times negative 20 would be positive 400, the radicand. Excellent. And part B, right? Taking an even root, pardon me, even root, negative number inside, another negative radicand, and we set it in 7 part A, said it earlier in the lesson. Even roots of negative numbers are not real numbers. Right, not a real number. Okay, that's all we're going to say. Alright, moving on. Alright, so this is the last page of square roots here. Then we get into some higher roots, cube roots, fourth roots, fifth roots, after example 10. Alright, so example 9, part A, they want the negative square root of positive 225. So that'd be negative 15. And again, you can check this. Take negative 15, raise it to the second power, and you indeed will get the radicand positive 225. Here, once again, I have an even root, square root of a negative radicand. Right? So there is no number you can square to get negative 9. There's no real number that you can square to get negative 9. So this is once again just not a real number. And that's all we're going to say for right now for these kinds of problems. Alright. Okay, example 10, part A. Hey, got the same issue, right? Got an even root of a negative number. There's no number you can square to get negative 49. Right? 7 squared is positive 49. Negative 7 to the second is positive 49. There's no number that you can square to get negative 49. So once again, this is not a real number. And that's all we are going to say for right now. Over here, this is okay. All right. We have what's the negative square root of 256? Positive. The radicand is positive, so we can take the even root. All right. So the square root of 256 would be 16. So this would be negative 16. So the result is negative 16. And again, let's check it. Take negative 16. This is a square root, so let's raise to the second power here. Negative 16 to the second is indeed positive 256. And I leave that to you to test it out. Okay. Now, those were all square roots, right? Examples 1 through 10. Example 11, we start getting into now higher roots. So you really got to pay attention to the index, the number inside the little crook of the radical symbol. So this is a cube root. So remember, what we're thinking of here is what number could I raise to the third power to get 216? Right? What number could I raise to the third power to get 216? and that would be 6, right? The cube root of 216, and again, this is an odd root, and every real number has exactly one real odd root. So I don't have to worry about positive or negative. You know, the odd root can be positive, an odd root can be negative. Right? It just depends on what your radicand is. But it'll always be real. Right? Odd roots will always be real for real numbers. But yeah, this is 6. Right? There's the result. And again, check it out. Take 6 to the third power, right? 6 to the index, and see, is that equal to the radicand? Well, 6 times 6 is 36, and then 36 times 6 would indeed be 216, so yes. And again, you can check it yourself. But that's how you're checking. You're taking your result, right, raising it to the index, and seeing if you get the radicand back, the expression inside back. Alright, so here's another. Now part B is an even root, right? Fourth root. So the radicand better be non-negative, which it's positive 256. That's cool. Pardon me. Wow. And the question now is, what number to the fourth power? Positive number. Remember, this is not negative, right? This can't be negative. The not negative root, fourth root, right? So what number, what positive number to the fourth power would give me 256? And again, this is just coming with experience here. I know this is 4, right? Because 256 is 2 to the 8th power, which is 2 squared to the 4th, 4 to the 4th, right? And you can check it, right? Take 4, take your result, raise it to the index, right? Is 4 to the 4th power equal to the radicand? Yes. Yes, it is, right? 4 times 4 is 16, times 4 again would be 64, times 4 again would be 256, right? Alright, so from here on out, we have problems with 3 parts. But it's still the same thing. You just got to pay attention, though, to the index. Is the index even? Is the index odd? Right? And that'll make a huge difference. So number 12, part A. Cube root of 27. That's just 3. Right? We saw this earlier. I wrote this up earlier, right? 3 to the third power is 27. Right? That works. So the answer is 3. Part B, what's the fourth root of 16? Well, that would be 2. And again, it's the positive fourth root, right? I know that negative 2 to the fourth power is also positive 16. But remember, when you see the symbol for an even root and there's no minus sign in front, they want the positive root, right? The not negative root. So this is just 2. Right? And again, to check it out, take 2 to the fourth power. And would that be the radicand? Would that be 16? Absolutely. 2 to the fourth power is 16. Then here we have the fifth root of positive 243. So again, odd roots can be positive or negative, right? You only got one, right? Every number only has one odd root. So I'm just thinking of what number to the fifth power would be 243, and that would be 3. The answer is 3. And check it out. Is 3 to the fifth power equal to 243? It would be. All right, 3, and just 3 times 3 is 9, times 3 again is 27, times 3 again is 81, times 3 again would be 243. 3 to the fifth power is indeed 243. Okay, yeah, so it should be simple, just as simple as the square roots, right? But you got to pay attention to the index. You got to pay attention to what root you're taking. Okay, here, part 13, part A. What's the cube root of 512? All right, cube root of 512. So again, this is an odd root, so the result can be positive or negative, but there's only going to be one possibility, right? Only one odd root for every real number. And you're thinking of what number to the third power would be 512, and that'd be 8. Right, and then check it. Is 8 to the third power 512? Well, 8 times 8 would be 64. And then 8 times 64 would be 480 plus 32. That would be indeed 512. Right, so the cube root of 512 is 8. Part B, what's again, the positive fourth root, not the negative one, right? Even root, there's a positive or a negative, but they want the positive with this symbol. What's the positive fourth root of positive 81? And that would be 3. Right, and again, check it out. Is 3 to the fourth power equal to, positive 81? Absolutely. Right, 3 times 3 is 9, times 3 is 27, times 3 is 81. Works out. See, what's the fifth root of 1? Well, 1's easy. That would just be 1. Right, because 1 to any power is 1. Right, 1 to the fifth power is definitely 1. Right, works. Okay, moving on. 14, part A. What's the cube root of 125? So again, odd root can be anything. Right? Every number has one odd root. Don't have to worry about positives, negatives, because it could be either one. We're just thinking of a number that, when raised to the third power, would give me 125, and that would be 5. Right, and again, check it out. Take 5 here, raise it to the third power. Is that equal to 125? Absolutely, right? 5 times 5 is 25, and then 25 times 5 again would be 125. Okay, next one. Even root, right? Fourth root, so the radicand better be positive, which it is, so we can do this. And they want the positive fourth root, right? Because remember, every positive number is going to have a positive fourth root or a negative fourth root, but this symbol means we want the positive fourth root. All right. So what number raised to the fourth power would give me 1296? I think that's 6. Let's check it. Take 6 to the fourth power. Is this equal to 1296? Well, 6 times 6 is 36. Times 6 again would be 216. Yes, times 6 again would indeed be 1296. So yes, 6 is the answer here. Right? The positive fourth root of 1296 is 6. Last one here, 14 part C, you got the fifth root of 1024. Now I know that 1024 is 2 to the 10th, so that'd be 4 to the 5th. So this is 4. The answer is 4 here. Right, and again, check it out. Is 4 to the 5th power equal to, equal to 1024? And yes, it would be. I promise you can take 4 times 4 times 4 times 4 times 4, right, and see if it's 1024. And it is. All right. So I think the remaining problems have all negative radicands, right? Negative numbers inside the symbols. So you really got to pay attention to whether or not you're taking an odd root or an even root now. So C15 part A, B, C, all the radicands, right, all the expressions inside the symbol are negative. For part A, we have a cube root, an odd root, so we're fine. Odd roots, you can do the odd root of any number. The cube root of negative 8, that would be negative 2. It's totally fine, right? Because if you take negative 2 to the third power, you're going to get negative 8, right? Negative 2 times negative 2 would be positive 4, times negative 2 again would be negative 8. Right? A negative number to an odd power is a negative result. And a simple way to do odd roots of negative numbers as well is if you know the odd root of the positive number, just take the opposite, right? The cube root of positive 8 is 2. meaning the cube root of -8 will be -2. It's really that simple. Okay. Part B. I'm taking an even root, fourth root. The radicand is negative. And so that is bad, right? There is no number, no real number, I could raise to the fourth power and get -81. Because if you take any real number, raise it to the fourth power, an even power, the result will be positive. It can't be -81. So, as with all the other ones with an even root of a negative number, we're just simply going to say for right now that this is not a real number. Has no real number value. And that's it. Now the next one's an odd root. Fifth root you can do. Fifth root of positives, fifth root of negatives, totally fine. What's the fifth root of -32? That would be -2. And again, check it out. Take -2 to the fifth power, and that would be -32. Remember, a negative number to an odd power will be negative, and that works out, and this worked out earlier too. Great, so the answer is -2 for that one. Alright, moving on. Example 16. Part A, odd root, cube root. So I can do the odd root of anything. Right? The cube root of -64 is simply -4. Right, because if you take -4 to the third power, you would get -64. You'd get the radicand. Right, great. And then, oh boy, even root, fourth root, negative radicand. That's bad, right? For now. So this is just simply not a real number, and that is all we are going to say for this section, for this video at the moment. Okay. Part C, odd root again, so totally fine. Take the odd root of anything. Fifth root of -243 would be -3. Again, check it out. Take -3, raise it to the fifth power, and would you get -243 back? Absolutely you would. Right. So -3 is the correct result. Alright, I got one last page here. Two more examples, just a bunch more parts. Again, all of these last examples have a negative radicand. So 17 part A, odd root, cube root of -125. So we're fine. What number to the third power would give me -125? Well, that'd be -5. -5, right? And again, check it out. Take -5, raise it to the third power. Right? This is a cube root. Is that -125? Absolutely it is. Right, here we have the fourth root, even root, another even root of a negative number. Yikes, right? Remember, these even roots of negative numbers, once again, are just not real. They're imaginary, and again, we'll talk about imaginaries in a future video. For right now, we're just simply saying that's not a real number and ending it. Because again, there's no number, there's no real number I could raise to the fourth power and get a negative result. Get -1296. 6 to the fourth power is positive 1296, not negative. -6 to the fourth power would be positive 1296, not negative. So I know I've said this a bunch, but no real number raised to an even power will give you a negative result. Part C, we're back to an odd root. Fantastic. What's the fifth root of -1024? Now we saw the fifth root of 1024 earlier. That was 4. So this would be -4. And I said that earlier. If you're taking an odd root of a negative, that's just going to be the opposite of the odd root of the positive number. Right? And again, double check it. If you were to take -4 and raise it to the 5th power, you would get -1024. I promise you, right? That does work. All right, then the final example, final 3 parts here. Number 18, part A. Again, your cube root of -512. Well, earlier in the video, right, we saw the cube root of +512 was 8. So the cube root of -512 is -8. And check that, right? Take -8. If you raise it to the 3rd power, would you get the radicand? Would you get -512? And yes, absolutely you would. So -8 works. And then once again here we have an even root of a negative number. This is not real. Just like part B of number 17 and earlier parts too. Right? This is just simply not a real number. There's no real number you could raise to the 4th power to get -81. Right? 3 to the 4th is +81. -3 to the 4th is +81, but you're not getting -81 ever. And then finally, probably one of the simpler ones you've seen, the 5th root of -1 would just be -1. Right? The 5th root of +1 was +1, right? So the 5th root of -1 is just the opposite of that. Remember, odd roots of negatives are just the opposite of the odd root of the positive. And again, you can test it out. Take -1, and if I were to raise that to the 5th power, would you get, the radicand back? Would you get -1? Absolutely, you would. All right. So yeah, the first, like 30 minutes of the video was a lesson. And then after that lesson, all the examples were pretty simple, I feel. So I'm hoping that, going through these 18 questions and that lesson at the beginning of the video, I'm hoping that, watching all this stuff helps you out when you're working on simplifying nice, easy roots on your own. And thank you very much for watching.